So we're going to go through how some of these examples affect one of the chloropleth maps that we looked at now 3 weeks ago in the last lecture. So if you remember, chloropleth helps you compare data sets between different regions or areas. So it's often used for counties or states or on a national level. But it's very important when you're creating a map like that, that you have normalized your data so that the size of those areas no longer impacts. So that wouldn't matter if you were doing something that's arbitrarily symbolized by a grid, or I think we talked about polygons way back at the beginning of the class, how hexagons lend themselves really well to this type of mapping, because you can nicely bin your data into consistent areas that are very effective for mapping. But if you're not going to do that, if you're going to stick with physical borders or political borders, then you need to make sure that you've normalized your data in order to utilize that information. I just got a warning that my internet connection is not great. So I'm sure that I can do anything about it, but I can try to shut everything else off. So anyway, this is something that we talked about a little bit before, but I just wanted to give you guys a reminder of what a chloropleth map is. So this was the example that we saw previously. This nice little section of northeastern United States, a place that feels very far away now. And this is a fairly classic use of a chloropleth map, is to look at abundance within an area, whether it's people or plants or voters. We care about people, so we tend to map people a lot. So again, this information has been normalized because you've taken your persons per square mile. So a very large county is not going to draw more attention just based on the fact that it's large. And this is something really important when you're looking at boroughs in Alaska, because there's a lot of difference in size and population and all kinds of other characteristics between our different regions. Okay, so this is where I talked about how we bin or classify our data sets. There's a lot of different ways to approach that. So there's equal interval, which lends itself really well to making a clear-cut legend and makes sense to us, but doesn't necessarily represent our data in a very meaningful way. So we'll look at that a little bit more when we look at some data sets. One of the more common approaches is what's called Jenks natural breaks or natural groups. That's a statistical algorithm that's applied depending on the number of groups that you would like to make and how your data is clumped. And then there's some other statistical approaches that create less flexible categories than the Jenks natural breaks, but they're more predictable. So we'll look at the effect that each of these has on a data set. Hi, very loud cat. So these are two different type of equal interval. There's the equal interval example in that each of these will be a defined extent. So they've chosen 3%. So each of those groups is 3%. And I had a little bit of trouble understanding this example. I believe what it's trying to tell us is how many toddlers there are in each of these. I can't think of any other reason or any other explanation for what % of population under 5 means. But you can see there's more toddlers along that one little band of counties along that river. So if you keep an eye on that, and then also the areas that have lower quantities of toddlers, you can see how each of these selections has a huge impact on your map, right? Right away, if we go to the defined interval, and the only difference between equal interval and defined interval is that we have told it we want 5 intervals on the right, and it has selected 5 intervals between 1 and 20 versus the equal interval we've told it we wanted intervals that were 3 in width, so it went from 3 to 18. And by changing up where those borders are in those bins, we've lost the understanding of those regions that are fairly widespread on the left, but not so much on the right, that have lower numbers of toddlers. And that's not necessarily a bad thing if the variation in that data was very small, right? You may have just selected a bin at 6% that happened to drop some counties in that lower bin that's hidden in the defined interval, but maybe the variation was like between 5.9% and 6.1%. So there's a responsibility for the cartographer to understand their data, and also very important to understand your own biases or the biases of whatever organization you're trying to represent, and understand how they might be influencing the representation of your data. And you can take that 2 different ways. You can either use that to make sure that your data representation is not biased because you're trying to represent what the data is to the public in an unfiltered way, or you can understand how that bias can be used and you can apply it because maybe you're trying to make a point or send a message. And obviously there's a lot of ethics that goes along with that, that really vary widely on what you're trying to represent. But as part of the background of knowing that statistics is designed to interpret data for you, and therefore twists that data in a lot of different ways. All right, so those are both equal interval systems. And then we have the quantile system, which looks at the distribution of data and makes the groupings equal. So your range in your numbers of percentages may not be the same, like the range from 7.8 to 18% is obviously much wider than the range between 6.8% and 7.2%, but it's trying to make each of those categories equal with each other. So while this map looks like there's a lot more going on, it's probably more important for somebody to look at this legend and say, okay, these dark blue categories where I have really high numbers are a really broad range, and they could mean a lot of different things. It doesn't necessarily mean that every dark blue feature on here is 18%. That'd be a heck of a lot of toddlers. You would notice if you walked up and down that river that there were that many toddlers there. But it's probably 1. And the rest of them are down more at 7.8. Yeah. So the quantile has its place, but it's also, I think, a little bit harder for the viewer to take in and recognize the fact that there's numbers that mean something in that legend that they should be paying attention to, because we are so drawn to the color and the map that we often overlook the legends. So a system that was developed that is pretty widely used because it relatively fairly represents a lot of different data sets without a lot of effort from you. The software is doing a fair amount of computation to mathematically figure out what you and I would recognize as groups. So if we had a data set that had a high spike down low and then a spike in the middle and a spike at the top, our eyes could go to that and say, okay, I want to group this group in one, and I want to group the middle group in another, and the upper group in another, and we could draw lines in there somewhere. But we're trying to get away from that, right? We're trying to use a GIS system, and it's supposed to do that for us. So there's a lot of math that goes into the Jenks natural breaks system that achieves what I just described in saying, okay, I want 5 groups and I want you to figure out where they make the most sense, computer, go. So it's a pretty cool system. And I think if you look at the map for this, you're still seeing those lighter colored areas of lower numbers. You're still seeing the emphasis of higher percentages along the river. So it's probably capturing some meaningful information here while still giving you the background variation of those other areas and not just totally wiping everything out like this defined interval map did. So you're not being locked into this set, consistent, calm, familiar range in your legend. You're jumping around a little bit. You know, some of them are 3%, some of them are 8%. But you're visually representing the information on the map in a little bit more immediately recognizable way. And I just realized it's 5 o'clock. I think we probably just want to finish up and keep going. There's not a ton left, so apologize. If anybody needs desperately an emergency break, I can stop and get a drink of water, but I can also finish up. Okay, hearing none, we'll finish up. And I will drink coffee water. Gross. Okay. And then 2 more statistical measures. I think these are good to pay attention to when you understand the distribution of your data, which sometimes ArcGIS will visualize for you if it's a raster data set. I think it's a little bit harder unless you go and create a graph on your own to understand necessarily how your data is distributed, unless you look at some of those statistics. But if you know that you have a normal distribution, which is, right, the standard distribution is the normal distribution of the population around some mean, which is a fairly natural, common representation of all kinds of data sets in a normal sampling of a lot of individuals. Sorry, that was harder to put into words than it should have been. That's your standard distribution, and that's where we get the concept of standard deviation. Or a geometrical interval where you have a natural skew to your data, where you have a lot more, apparently, well, they're grouping their data with this emphasis on that 18% is a lot of toddlers. There's one county that is really skewing all of that data, and the rest of them are geometrically distributed from there. So I think for these 2, it's helpful to have an understanding of your data. You can also just really easily play with these in ArcGIS and look at all 6 of these types and see from the maps kind of how that represents your data, and maybe that will also show you something. But anyway, these are 2 more statistical approaches to classifying your data set. I think it's unfortunate that the final one has red in it. That's not the point that we're trying to make. We're not looking at divergent sets here. But you can see how that would have a fairly similar impact to the Jenks natural breaks. So it probably means what we're looking at here is a relatively standard normal distribution similar to the standard deviation. And the Jenks has happened to, catch on to that trend. So I have 2 different things linked here. On the first one, the first slide, I linked the ArcGIS Pro description of how you use each of these color systems in your symbol classification. But it doesn't get as in depth into how each of these works. So I also left in the link that he had to the ArcMap article about this. So if you were interested in some background reading on statistical color distribution. Okay. So we've talked a lot about the purpose of GIS and what we're trying to achieve with it. A very large percentage of the time, maybe less than was initially used, our end goal is to produce a type of map. So it's very important that we consider in our selection of different map elements and our application of different map styling, how each of those elements affects the final product. Because if our final product is confusing, we've wasted all of the effort that goes into collecting that data set and understanding that metadata and applying, getting all the information into one map. The weekend that I spent trying to get things into the right projections so that they could all live in the same web map, only to find out that I built a web map where I hadn't enabled photo capture and had to start all over from the beginning, and then found out that it was all too big to download in Hawaii anyway. So we put a lot of effort into these. It's important that we don't break down at the end when we're making your map and forget that there's a human being on the other end of that you're trying to influence in some way, right? For me, you're trying to get me to give you a good grade, which I'm naturally inclined to do. But if you're trying to convince me to go dig for gold on your claim, your map better represent to me in some meaningful way why one place is better than another. And because I happen to understand statistics, you better not do that in a misleading way. Because statistics is a tool that can be abused. So, our last point of discussion, I'm pretty sure these are maps actually created by my predecessor in this class, the professor who used to teach it. And I think they're really interesting examples because they're clearly very different mapping perspectives of fairly similar data sets. But I think they both have their place and their value. So if you guys want to discuss at all, well, I'm asking you guys to discuss what is the purpose of the left versus the right? What is the gist of the top versus the bottom? And I'm still trying to figure out a little bit myself, what's the difference between A and B and C and D other than year? Because there's got to be a message behind this data, right? We're meant to look at a comparison between 2014 and 2018 and understand it. And we're also meant to look at a difference between precipitation anomalies and the spatial representation of vegetation health and draw some conclusions between those. So I'd like to hear a little bit from you guys after you've had a chance to absorb these maps. So Jeremy in the comments pointed out that on the left, the topography behind the terrain features overshades the information from the data set, which was my initial thought too when I saw these side by side. I did think it was somewhat helpful to see, and this could be a misinterpretation of the data as we saw in some of our topographic maps before. If somebody uses a green to brown color trend in a topographic map, our brains immediately interpret that as vegetation and not vegetation. Which if this is an aerial image laid over the ocean, it could be. So it's hard to say. It looks like if anything, it's the same image behind both years. So we might be jumping to some conclusions, but it looked like there was vegetation information given in that topographic map that obviously would be missing on the right. But if you compare left to right, I think that terrain is more visually distracting than the information that's given on the right. I'm sorry, I use the word topography, but probably a terrain map is more applicable to that image slash, could be an elevation model, could be a merging of the two. But I could also see how topography would influence your vegetation and your precipitation, especially in a region like Anchorage, where our storms are very much influenced by being on the lee side of the mountains. So how does the usage of the agroecological zones on the right influence interpretation of the data?
What was the question again?
How is his, so on the right, he's added the agroecological zones. I think I edited out the part that said that that was at the request of his client, was to add those zones in and see how that interacted with the precipitation and vegetation health. Can you see any trends in the data that would make that meaningful? How about the usage of a vegetation survey along with regional data like this? Is it fair to draw conclusions from point data about precipitation on a regional basis? What about those areas where they don't appear to have any rain sensors? Does that mean they don't get rain? So I think that's you know, a good indicator of the power of maps to influence our perception of the data. When you start looking at the distribution of all types of scientific information around the world, you start to see how heavily influenced our data collection is on our modeling of the world. You start finding out that Fish and Game does huge amounts of their bear monitoring in heavily populated areas. You start to wonder, okay, what about all those bears that we don't monitor outside of heavily populated areas? And the same thing applies to mapping data. We have lots of information and data sets about urban areas, but clearly very sparse information about non-urban areas. And so by using a point-based representation of that data, we're influencing the viewer's interpretation of it. And I think that's one of the points. I'll try to reincorporate that discussion of the hexagon data, or using some sort of normalized approach to represent your data over an area might be more representative of precipitation information, which is very regional, not very localized. Could potentially be a little bit more meaningful and show a little bit more about the relationship of that data to these farming areas, versus understanding that you're going to have a lot of feedback from farmers, not so much feedback about vegetation where there's no farmers. And then, as you pointed out, we have on the left a far more detailed and informative and arresting ground that can distract the eye from our feature. So is that important enough to do that, or is it just a pretty picture? What else do you see between the two? Are there any differences in map elements that are meaningful? Oh, he didn't forget to label C and D. He just had to move it because of the agroecological zones legend. Yeah, So that's maybe a good recognition of adapting your symmetry to adding additional features. What else? What was the Sesame Street game? One of these things is not like the other. What differences can you identify, and how do you feel like they affect the second product on the right? Come on, I know you guys are in there. Oh yeah, that's interesting. I didn't notice that South Sudan is labeled differently between the two. I don't know enough about the history of the area to recognize that. Is there anything else you see different in the labels? How about the place names? What's the difference between left and right? Yeah, so there's two things. There's case and font, and I think it's a little bit interesting. So on the left, all of the labels are pretty well balanced. There might be a slight difference in line weight on Nairobi, and it looks like Kenya might be a little bit bold. So he's trying to draw attention to Kenya. That's his area of focus. But he hasn't heavily distinguished between countries and cities. There's not a huge amount of difference to my eye between Nairobi and Sudan, but on the maps on the right, he's gone all caps on the countries. So it's pretty quickly identifiable that there's a difference between Nairobi as a city and Tanzania as a country. Again, that may or may not be important to what you're trying to achieve, but it does seem a little bit potentially confusing on the left that you've treated those two different feature types so similarly. What other elements are different between the two? There should be some that jump out and catch your eye because this is mapping. And what do we care about on maps?
The one on the right has a north arrow. And
exactly. We care which way is north, always, except for when we don't. But there's a difference between the two. He's added, for some reason, he's added a north arrow and a scale. And since this went through a review process, I assume that's because some reviewers said it's a map, it has to have a north arrow and a scale. Do you think those added anything to your understanding of this information? Did you have any doubt on that first map, which way was north? And did it enter into your attempts to understand what he was trying to tell you about precipitation and vegetation? I think I talked too long today. I broke you guys. Oh yeah, I almost didn't see the star symbol, Tucker. That is an example of a not so visible symbol choice. It kind of blends into those dots there. It shows up fairly well in A and B, but I've been staring at C and D and it kind of blends in there. But yeah, adding that north arrow did nothing for me. Potentially the 200 kilometers could be somewhat useful if you're not familiar with the scale of the area. But that one also I could take or leave on this map. So don't let your reviewers bully you. But also recognize that some people may not be familiar with the area, so some of this stuff might be useful and important to them. I, as a water-focused people, find myself wondering if it would be helpful to know that I have an ocean on one side, and I'm assuming that's a lake between Uganda and Tanzania. There's a shameful admission that my African geography is very poor. But probably labeling them would be distracting in this case. We're talking about pretty small little figures. These are blown up here, probably larger than they were in the original. So adding a lot of additional data would probably be distracting. Okay, so hopefully, I probably should have put some more pretty pictures of maps to help inspire you, but hopefully this information has at least opens up the concept and the thought process about what is my map trying to say and how effectively is it saying it. And then also just some basic principles of good visual production of graphic design. So this is a rather confusing, blurry looking list of links, but you guys can poke around in them. A couple that I really found helpful in understanding graphic design principles were this paper mill store blog. It's got a lot of really great information and it's all free on the web. And it talks to you about how all these visual features are used to guide your interaction with advertising. So it probably does a much better job of explaining Gestalt theory than I did. You can look at how grouping and placing your images affects the feeling of motion, when it's okay to break the rule of thirds if you're trying to make a point with symmetry. And you might look at this and think, well, what does that have to do with mapping? What it has to do with is how laying out your map might affect the way that people interact with it. So moving a river through a large area of your map is going to draw focus to that river because it's become a defining feature of multiple regions in what I've gridded out in my head without realizing it. It also helps you identify the fact that the alligator is scary. There was a link. Sorry?
I was just saying that made me laugh out loud. That was pretty funny.
Yeah, stay away from the gators, Florida. There's a really good story map. I think it's this last one. I hunted all over to try to figure out who the author of this lecture was and see if they had any more good lectures I could steal from. And I couldn't identify that anywhere in here. Bonus points to anybody who can, but I spent a fair amount of time looking at the code behind the website and still failed. But the reason I liked this, other than that it covers a lot of the same stuff that I talked about with some more pretty pictures, it has a really great example from Alaska. This was developed by Jim DePascal, who used to be the cartography manager for the company that I started out mapping for, and then went to work for the Matsu Borough and run their LiDAR program, which is one of the most sophisticated LiDAR programs I've ever seen in a small community, which resource-wise the Matsu is, but they have a huge amount of area to cover and manage. And they've done that partly by collecting new LiDAR data every 2 or 3 years in a meaningful rotation. So this is an example of a map that Jim developed, partly just because he's amazing with ArcGIS, and I don't think I can blow this up for you. Oh, if I use my tools. No. Story maps are a little weird in how they zoom. So I can't pull it out, but if you look at the elements here, he's balanced his text beautifully around this map area, which has a pretty clear visual representation. Knowing Jim, there's probably a fair amount of thought that went into in the color map here and where it shows snow and where it doesn't. There's probably a correlation between the time of year at which the snow is at that elevation. But then, you know, things that you can see are the balance of white space around this area. You know, he's used the extents of the LiDAR and the topography to control the text, and then simplified some of the other elements by placing them in a little bit more balanced way around the map. So there's a lot of different ways you could look at this map and probably have differences of opinion on, you know, every little part of it, but on the whole, it's well balanced. It uses color effectively, And I don't think any of the features detracts from any of the other features. So that's one of the sites that I shared with you. There's a lot of other really good, sorry for the zoom, pieces in this story map. It's also a cool example of story maps, which are an Esri product, but are frequently used in ways that have nothing to do with mapping, because it's just a cool, cool web tool. A couple of these are just other informative things that I pulled out, some good blogs on cartography systems, that color sampler that I showed you. The Principles of Design handout is linked here. This is the article that I pulled from for a couple of the figures. So there's a lot of information out there that I couldn't pack into one lecture, and it's out there for you. So our lab this week, we're going to start on lab 5. I haven't decided yet how to make that a manageable bite. There are 5 different maps that he wants you to create in that lecture, and I want to make sure that you have the time to put thought into your layout and apply these principles. Just slapping together 5 maps isn't necessarily the way to do it. So I haven't figured out how we're going to break that down yet. But that's what we'll be starting with on Thursday. Jeremy had a question. How often do I run into conflicts with the client's message? So my conflict tends to be more often internal, the message that we want to present to the client. It's somewhat seldom that I get feedback on a map, though I say that having just redone a report where I downloaded some data from the state website that I had you guys go to, Alaska Mapper, downloading boundaries, and I used that to confirm some imagery, and it turned out that the state data had been taken from some poorly referenced imagery. So I put some boundaries in the wrong place, which led to misinterpreting some wetland areas. So luckily our client caught that. And we were able to rectify that before they went to permitting and design. So that's more of a guffaw on the survey front and on the data validation front than a style. I would say that a lot of my clients are either uninformed or maybe uninterested in digging into the details of mapping. But my goal is to put something in front of them that's already refined and presents the message that they need to understand.
No, I appreciate that. I was just trying to understand, like, is the obligation of the map maker to present, and I realize this probably differs from the role, whether you work for a governmental agency or private or et cetera, but is the kind of understand, like, is the obligation of the map maker to tell that story objectively, or is it to present what your client wants? Yeah,
again, that's going to be very situational and somewhat dependent on the map maker, but probably more on the situation, on the data that you presented. I think I told you guys I took out some rather political slides because I don't want to turn this class into a political discussion. But there's hundreds of examples out there on how you can use map making to change opinions and beliefs. And I hope that anybody that's working in that field will at least at the minimum not do so blindly. I did my senior project on interpreting statistics of 2D modeling of gold data sampling. So I had a statewide database of stream sediment samples from all over Alaska that had gold quantities. And I can by God, hand you a map of any section of Alaska and make you go out there and dig for gold. That does not mean that there's gold there in any meaningful quantity, but I can make it look that way. So again, some of that comes back to your personal ethics, but probably more like what's the goal of your organization and what's a reasonable amount of interpretation of the data, because it doesn't do you any good for me to just hand you this raw data table that I haven't done any work on, because you're not gonna know how to put that into context. So like many of the things we've discussed today, it's a little bit of a sliding scale and very much open to interpretation. But the key is knowing that the issues exist.